Using AI to make a video is pretty good, right? I even created this intro video using VO. But here's the thing, while we use huge models to make cool videos, we actually do not need massive parameters just to get good reasoning. Everyone thinks you need 70 billion parameters to think. I'm here to prove you only need 1 billion if you train it the right way. Welcome to Transparent Intelligence. My name is Oikantik, and for the Google Tunix Hackathon, I built a solution. I didn't just train a model to answer. I used Tunix and Gemma 3.1b to build an AI that shows it work before it speaks. So I built this pipeline on a TPU V5E where slice using Google's Tunix library instead of standard fine-tuning. I utilized GRPO, Group Relative Policy Optimization. For every single input prompt, my model generates a group of 4 different reasoning paths in parallel. Tunix then analyzes these groups, scores them, and update the model to favor the logic that actually makes sense. So for optimizing training with data, GSM 8K data I used from the demo, and leveraging JAX and Flax for efficiency, and harness power of TPU for performance. Now these are the challenges I faced. So let me show you. I want to show you exactly how I solved this in the code. Here is my experimental attempt, that is version 9. So the model actually learned to game the system. It would skip the reasoning and step entirely just to output an answer and get a quick reward. So that's failed, and the initial approach that I previously did by theoretically. So here is, look closely at the reward function block. So here is, I implemented a composite verifiable reward. I added a strict logic that checks for specific XML tags. If the reasoning tag is missing or empty, the model gets penalized immediately. This code change was the key to forcing the model to actually think. I guess you have got this when I told you earlier, and this is what I am talking about. As you can see in the result, the champion model consistency breaks down complex words problem into variables. It derives the solution step by step, enforcing strict transparency in the Python code. I achieved a 63% verifiable accuracy score, significantly outperforming the baseline. It's not just accurate, it's explainable. So you can check this out on your own, because I don't waste time on these outputs because I think I don't have time. And this is the conclusion I get up with, that is version 9. Version 9 might get right answer sometimes. Version 4 builds trust, It proves the model isn't hallucinating. It's actually thinking. The chain of thought capability makes the version 4 the only valid submission for a reasoning. So this project proves that we don't need a massive 70 billion parameters models to get reasoning capabilities. We just need better training techniques. So with Tunix and Gemma 3, I have proven that we can build AI that is transparent, safe, and trustworthy. The full code of both versions available in my submission. And special thanks to Google Tunix team for open sourcing such as a powerful JAX native library. This project would not have been possible without the seamless integration of Tunix on cloud TPUs, which allows me focus on the reasoning logic rather than the infrastructure. Here is a little quote, and thanks for watching.